This is the 8th video of the tutorial about history analysis in RayJack ONE. In this video, we will learn how to interact with the history settings, which allow us to control what data is collected by the history detector during ray tracing. In the previous videos, we have already seen commands like history.settings.storeAllRayData equals true, or history.settings.recordAllInteractionData equals true. In order to understand what these commands mean, let us have a closer look on how the ray tracer and the history detector interact during ray tracing. Consider a ray that is created in a source and then undergoes multiple interactions with the optical system. During each of these interactions, including the ray creation, the history detector takes a snapshot of the interaction data, which includes the interaction position, the ray direction, the ray flux, the interacted object, the interaction type, and so on. Because the collection of the interaction data is an ongoing process during ray tracing, we also say that the history detector records the interaction data. After the final interaction of the ray with the optical system, which could, for example, be the absorption by some surface, the ray properties of the ray in the final state are written into the history detector. We also say that the history detector stores the ray data. Once the history detector has collected the ray data in the final state, the ray object itself is deleted from memory and the next ray is traced through the optical system. When the ray tracing has finished, the interaction data can be inspected in post-processing, either through the paths or through the interaction log. The ray data, on the other hand, is used to construct the ray copies, which are ray instances that mimic the rays as they were in their final state during ray tracing. The command history.settings.storeAllRayData equals true means that after the final interaction, all available ray properties are stored by the history detector. The command history.settings.recordAllInteractionData equals true means that during each interaction, the full range of interaction data is recorded by the history detector. These settings are suitable in most applications because after ray tracing, the full range of history data is available for post-processing. However, in some applications, a very large number of rays is traced. Storing all ray data and recording all interaction data then implies a very large memory footprint, which can become prohibitive. In these cases, it makes sense to restrict the collected interaction data and the collected ray data to those data items that we will actually use after ray tracing. So if we already know that the interaction positions will be relevant for post-processing, but the interaction ray directions will not be used, it can be useful to restrict the collection of the interaction data to only the ray position and to exclude the ray direction from the recorded interaction data. So let us assume that we wanted to trace a very large number of rays and that we already knew that after ray tracing we only needed a limited set of history data for our analysis, given by the ray positions, the ray wavelengths, the interaction positions, and the paths. In order to set up the history detector accordingly, we can set the store all ray data and the record all interaction data flags to false, and then selectively activate only the settings that we need. History settings store wavelength equals true. History settings store position equals true, history settings record position equals true, and history settings record paths equals true. Record paths means that all the interaction data is collected which is needed for path analysis. This is the interacted object as well as the interaction type and so on. Also note the difference between the commands store position and record positions. The record keyword always refers to interaction data. So record positions means that the interaction positions are recorded, whereas store position refers to the ray data, which means that setting this to true only implies that the position of the ray in its final state is stored by the history detector. In addition to these flags that allow us to switch on and off single history settings individually, there are also a couple of meta flags that allow us to switch on and off several history settings collectively. The store all ray data flag and the record all interaction data flag are such meta flags. In addition, there is also history settings record trajectory. This is a flag which will switch on all the interaction data that is needed for the display of ray trajectories after ray tracing, or even history settings record slow motion equals true. So this will switch on all the history settings that are needed to produce slow motion videos in post-processing. So let us run this script until this point and then inspect the history settings that we have made through the history settings dialog, which we can find in the menu under Analysis History Settings. The history settings dialog is partitioned into three sections. The first section is for the interaction data. The second section is for the ray data of standard optical rays. And the third section is for the ray data of specialized rays, such as polarized rays or differential rays. In the interaction data tab, we can see that paths and positions have been activated together with the trajectory and the slow motion, and these have then implied the optical path lengths and the media settings because these are needed for a slow motion video. In the base ray data tab, we can see that position and wavelength have been activated together with some other properties that are needed for slow motion and trajectory generation. In principle, we can use the history settings dialog also in order to manually activate and deactivate individual settings. For example, we can also now include the fluxes of the interactions. However, note that the history settings need to be made between the command simulation split, which defines the simulation, and raytracer.trace. So we would first need to run this command, then we can do the history settings either by script or interactively through the history settings dialog, and only then we can run the command that triggers the ray tracing. Let us finally discuss what happens if we set up the history detector to collect only a part of the available interaction and ray data. Remember that the interaction data is used in post-processing to generate the paths and the interaction logs. If we query the paths, for example with the command history.gridView, although the recording of paths has not been enabled in the history settings, we will simply get an error message telling us that this operation is not possible. Next, if we inspect interaction logs after a ray tracing simulation where the history detector was set up to record only a part of the available interaction data, we will see that the available interaction records show a mix of valid interaction data entries on the one hand and default data entries on the other hand for those properties, the recording of which has not been enabled in the history settings. These default values are either not a number for floating point properties or vector type properties, or none for object type properties. Ray data, on the other hand, are used in post-processing whenever the history detector constructs ray copies. So, if we set up the history detector to store only a part of the available ray data, but in post-processing we query ray copies from the history detector, these ray copies will be initialized with the valid ray properties from the history detector as far as these have been stored, and the other properties will be just initialized with some default values. These default values are not a number for floating type and vector type properties. They will be none for object type properties, and they will show a large negative number for integer type properties. In order to illustrate this behavior, we pick a ray and inspect the interaction log for that ray. For each interaction record, we print the position, the direction, the optical path length, and the medium to the console. Afterwards, we take the first ray of the list of ray copies from the history detector, and for that ray copy, we print the position, direction, wavelength, the current medium, and the number of scattering events to the console. We run this script with the full range of history settings, which means we set store all ray data to true and record all interaction data also to true. Let me run the script. We can see that the interaction records are filled with reasonable entries. Also, the ray copy has reasonable entries for all of the shown properties. Next, we run the same script, but we restrict the history settings. So store all ray data is set to false, and record all interaction data is also set to false. Instead, we only store the position, and we record only the direction. And then we run again the script. Now, when we look at the interaction records, only the direction shows a reasonable entry, whereas the position is set to not a number, also the optical path length, and the medium is set to none. For the ray copy, on the other hand, we can see that the position is set to a reasonable vector, whereas the direction is set to not a number, also the wavelength. The current medium is set to none, and the number of scattering events is set to a large negative value. So let me wrap up. In this video, we have learned how to interact with the history settings. In case that a history analysis is planned, it is recommended to set history settings store all ray data to true and history settings record all interaction data to true. This enables the collection of the full range of history data and avoids confusion or unexpected behavior. However, if memory consumption is an issue, we can also disable the collection of all history data and instead only selectively enable the collection of individual ray data or interaction data items. However, in that case, we need to carefully interpret the resulting interaction logs and ray copies in order to avoid misinterpretations.